This is a video for MEI Core Pure Mathematics, Matrices 5, 3x3 determinants and inverses, 5.1 minors and cofactors of a 3x3 matrix. You should already be able to find the inverse of a 3x3 matrix using your calculator. This is especially if you've got a matrix that only has numbers in it. However, you also need to know how to do this without a calculator. This is particularly important if you've got a matrix that involves algebraic terms. We should note that for 2x2 matrices, we already have a quick method of finding an inverse. In general, if you've got a 2x2 matrix that looks like this, A, B, C, D, and you want its inverse, then the technique is to, first of all, divide by the determinant of that matrix, and then to swap the leading diagonals, so D and A swap places, and change the sign of the other two, like that. However, for 3x3 matrices and higher, we need a more step-by-step approach, as the process is much more complex. Before we get started, let's just make sure that we know about some notation. We're going to be talking about a 3x3 matrix M, and if this is M, I'm going to use A, B, and C to represent the columns, and 1, 2, and 3 to represent the rows, and I'm going to use a small letter and number to represent an individual element. So this is a lowercase a1 to represent this upper left-hand element. Finding the inverse of M is 3 stages now. The first thing we need to do is to find the cofactor for each element. The next thing we need to do is to find the determinant of the original matrix M. And finally, we set up the adjoint of M and divide by the determinant. Some of these terms may be unfamiliar to you, and we're going to concentrate on cofactors for the remainder of this video and look at the other two in subsequent videos. In practice, we often reverse steps 1 and 2, and you'll see why later, but just simply think that if the determinant is 0, in the case of 2x2 matrices, we can't find an inverse, and a similar thing happens with 3x3 and higher. Okay, let's start by looking at the minors of a 3x3 matrix. So if you look at this definition, the minor of a particular element is found by eliminating the row and column that the element sits in and finding the determinant of the remaining matrix. For a 3x3 matrix, the remaining matrix will be 2x2. So if we want the minor element of A1, notice lowercase a1, if I want the minor for that element there, I remove its row and I remove its column, and I'm left with this matrix here, and I want the determinant of that matrix. So I want the determinant of -3, 7, 4, 2, and that's going to be -6, take away 28, which gives me -34. If we look at the cofactors of a 3x3 matrix, well, the cofactor of any element is the minor for that element, and then we apply signs according to this sign matrix here. And notice the signs alternate as we go across the rows and columns. And notice that the cofactor is denoted by a capital letter. So if I want the cofactor of A2, that would be denoted by capital A2. So if I want the cofactor of element A1, in this situation, the cofactor of element A1, well, that's going to be capital A1, and that's going to be equal to the sign from this matrix, so that's that sign there, so it's a plus sign, times the determinant of what's left when I remove the rows and columns that A1 sits in. So it's the determinant of -3, 7, 4, 2. And we've already seen that this came out at minus 34, and it's unaffected by this sign here, so it's just going to be minus 34. So if we look here at the cofactors of B1, I've removed here the row and column, so first row, second column, I've removed those, and I'm left with a determinant of minus 5762, which comes out to be minus 52. And from the sign matrix, and if you can't remember it, remember how to construct it, so you can write it down to remind you. You will remember with practice. So B2 is this one here, so it gets a minus sign, and the minus 52 gives me this result that the cofactor, capital B1, is 52. Another example, if I want the cofactor of C2, so remove its row and its column, I'm left with 3264 as the 2 by 2 matrix, find its determinant, and that's 0. And now I don't care about the sign matrix because 0 is always just 0, but you should remember plus minus plus minus plus minus, that the C2 sign should be a minus sign. However, of course, I still get C2 equals 0. So in this worked example, you'll see we're trying to find the cofactors of this matrix. And what we're doing is finding the cofactors of every element in the matrix. So I get 9 cofactors, and they are A1 to 3, B1 to 3, and C1 to 3. Notice the capital letters because they're cofactors, and they've had the signs applied to them. So the cofactor for little a1 is the determinant of this matrix, and it's affected by a plus sign. B1 is, if I take those out, you'll see B1 is this determinant, and it's affected by this sign, and so on across all the elements of the matrix. When we've got all of these cofactors, we can then go on to the next 2 steps, and our next video in the sequence, 5.2, is the determinant of a 3 by 3 matrix.